In this lesson, we're going to learn about primary trigonometry ratios. So a ratio is just a relationship between two different values of the same type, and we can write a ratio as a fraction where the first term in the ratio would be the numerator and the second term would be the denominator. So for example, you guys have 4 classes that you take and 1 period for lunch. So your ratio of time in class compared to time on break is 4:1, and we could write that as 4/1 as a fraction. So the first number became the numerator and the second number becomes the denominator. So for our primary trig ratios, that is what we're going to do. We're going to write our ratios as fractions. There's 3 different primary trig ratios, and each one represents a different ratio based on the sides of a right triangle. So each ratio has 2 of the 3 sides. So the sine ratio is a ratio between the opposite and hypotenuse sides. And if you recall, in the last lesson, we learned that we labeled the hypotenuse was always the longest side in a triangle, and the opposite and adjacent depended on which angle we were talking about. So this over here, this symbol, it's a Greek symbol called theta, and we use it as a stand-in for an angle when we don't know what the angle is. So whatever angle I'm talking about, the sine of that angle is the opposite divided by the hypotenuse sides in that triangle. The cosine ratio is the adjacent divided by the hypotenuse, and the tangent ratio is opposite divided by adjacent. And we can use SOHCAHTOA to help us remember that. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's take a look at a couple of examples to see how this works out. So to write our primary trig ratios, we are first going to shade in our reference angle. So in this first question, for angle T in triangle TRQ. So here is my reference angle. That's what I'm going to use to determine my opposite, adjacent, and hypotenuse. And we did this in a previous lesson. So opposite or across from the right angle is my hypotenuse. Across or opposite from the reference angle is my opposite side. And then the last side is my adjacent. Adjacent means beside, and this side is beside my reference angle, but it is not the hypotenuse. So my reference angle has 2 sides it's beside, but one of them is the longest, and it is the hypotenuse. So the sine ratio, so this time instead of using this theta, I know that I'm talking specifically about angle T. So I'm going to write the sine of angle T. So sine is equal to opposite over hypotenuse. And then I'm going to fill in the numbers here. So my opposite is 4 and the hypotenuse side is 5. So my sine T is 4/5. So that is my ratio for sine. The cosine ratio, and our short form is cos. So cos of angle T is adjacent over hypotenuse, and my adjacent side is 3 and the hypotenuse is 5. So 3/5 is what cosine of T is. And then the last one, tangent ratio or tan of angle T. So tan of any angle is the opposite over the adjacent. So from angle T, the opposite was 4 and the adjacent is 3. So this is all we're doing in this lesson. We'll do one more question, and over here we'll see that sometimes we are going to reduce to lowest terms. So we'll quickly label, we were using from angle M this time. So opposite or across from the right angle is the hypotenuse. Across from our reference angle is our opposite, and our third side, which is adjacent to our reference angle, is the adjacent. So the sine of angle M is equal to opposite over hypotenuse. Opposite is 3.6 and hypotenuse is 5.4. And just quickly remember that we do opposite over hypotenuse, so 3.6 over 5.4. Now both of these can be divided by 1.8, and if I divide by those numbers, I end up with 2 over 3 as my lowest terms ratio here. Let's make this smaller so we fit in for the cosine. Okay, so the cosine of angle M is equal to the adjacent over the hypotenuse. Adjacent is 1.8 and hypotenuse is 5.4. Once again, each of these will divide by 1.8. And so our lowest terms ratio here is 1 over 3. And lastly, we'll do our tangent ratio. Tan of angle M is opposite over adjacent. Opposite is 3.6 and adjacent is 1.8. Now here, if I divide 3.6 by 1.8, so I can divide each by 1.8 like this, or I can do 3.6 divided by 1.8, and that's going to give me 2. So there are my sine, cosine, and tangent ratios for angle M in this triangle.